Hello viewers, we have quite an interesting question from WASSCE and it goes as follows. A cylinder contains 2 moles of oxygen, 3 moles of carbon dioxide gas and 5 moles of nitrogen at a particular temperature. If the pressure in the cylinder is 210 newtons per square meter, calculate the partial pressure of oxygen and nitrogen. It's quite an interesting question, if I must say. So what do we do first? We would first and foremost get the mole fraction of both oxygen and nitrogen. From there, we'll proceed to getting the partial pressure of each of the gases. Okay, so to get the mole fraction of each of them, first we must get the total number of moles of the gaseous mixture. Then from there, we'll proceed to getting the mole fraction. So let's go. Total number of moles, let me call it NT, equals oxygen is 2 plus nitrogen is oxygen is 2, carbon dioxide gas is 3, and nitrogen is 5. So if we add everything, it leaves us with what? 10. So the total number of moles is what? 10 moles. So the next item will be to get the mole fraction, and mole fraction will be number of moles of a gas to the total number of moles. Okay, next will be mole fraction of a gas equals the mole fraction of a gas will be the number of moles of the gas, okay, over the total number of moles. Okay, so for oxygen, which is the first one, for oxygen here, I will call it NFO2, will be number of moles of NO2, which is for number of moles of oxygen, over the total number of moles in the gaseous mixture. So if I substitute, the number of moles of oxygen in the question is 2, the total mole fraction is 10. So NFO2 will leave us with 0.2. So 0.2 for the mole fraction for oxygen. Then for nitrogen, in the same manner, the number of mole fraction for nitrogen, N2, will be number of moles of nitrogen over the total number of moles. Okay, so the number of moles for nitrogen in the question is 5. The total number of moles is 10. So this will leave us with 0.5. This is the mole fraction of nitrogen, N2 here, please. Okay, then on getting these two items, the next thing we will proceed to would be the total the partial pressure of both oxygen and nitrogen. To do that, we would use the formula that partial pressure of a gas equals mole fraction times total pressure. So I'll be rubbing off the board to respond to that. Rubbing off the board. So I believe if you want to get this, you pause the video, you get it written. So partial pressure equals mole fraction. Okay, let me separate these two so that it won't look like one word. Mole fraction times total pressure. Okay, for oxygen, the partial pressure of oxygen, PO2, will be equal to the mole fraction, which is NFO2, times the total pressure, which is PT. So for oxygen, the mole fraction we got was 0.2. So it will be 0.2 times the total pressure, which is 210. So if we multiply this, let's quickly do that. Multiply this 0.2 times 210, it will give us 42. So the partial pressure of oxygen is 42 newtons per square meter. So let's go over to that of nitrogen. Nitrogen, okay? So for nitrogen, we got 0.5. So the partial pressure for nitrogen will be equal to the mole fraction of nitrogen times the total pressure. So the mole fraction of nitrogen we got here is 0.5 times the total pressure, which is 210. So half of 210 should be 105. So 105 newtons per square meter. It is this simple, my lovely viewers. It is this simple. Only if you pay attention to details. All right, so that's it. Even if you were asked to also find the partial pressure of carbon dioxide gas, it is also simple. I think that of carbon dioxide would be 0.3 times 210. It gives you the partial pressure of the CO2 gas, that's carbon dioxide gas. Thank you for watching. Remember to like, share, and subscribe to our channel.